Good evening, children. Good evening, children.
Good evening.
Hello,
Good
children.
evening.
Am I
Good
audible?
evening, ma'am.
Good evening. Very few responses. Good evening,
Good evening, ma'am.
Good evening. I've given you 4 questions as homework. You can check your answers. Who's completed? 4 questions were given as homework. Correct?
Yes, ma'am.
Yeah. Let me unshare my screen and ask you. So the first one, the AP, 18, 15 and a half, 13, so on till minus 47. The AP has 27 terms. I already showed you the answer. So the AP has 27 terms. For the second one, children, how many 3-digit numbers are divisible by 6? How many 3-digit numbers are divisible by 6? What's the answer for this one?
159.
Who's this?
Dirinesh.
Tiranesh, very good. There are 150 3-digit numbers divisible by 6. Very good, Tiranesh. Read out the terms of your AP.
102, 108, 114, till 996, ma'am.
Very good. Very good. Yes, you're right. There are 150 3-digit numbers that are divisible by 6. The third question was, find the AP whose third term is 16 and the 7th term exceeds the 5th term by 12. What are the values of A and D?
Ma'am, A is 4 and D is 6.
A is 4 and D is 6. A is 4. Yeah, right. Shreya? Was that Shreya?
Yes, ma'am.
Yes, you are right, Shreya. A is 4 and D is 6. And what is the AP?
AP is 4, 10 and 16.
4, 10, 16 and so on.
Yes, ma'am.
The fourth question, minus 37 plus minus 33 plus minus 29. So it goes on like that. So we need to take how many terms to get the sum as minus 180? You have the question with you, minus 37 plus minus 33 plus minus 29. So on, goes on till plus x is equal to minus 180. What's the value of x? What is the first term, children?
Minus 37.
Minus 37. What is the common difference?
4.
4 is a common difference. All right. And what is minus 180? What is minus 180? Is it an or sn?
SN.
Sn. So work with that. Sn is equal to minus 180. So n by 2 of 2a plus n minus 1 into d is equal to minus 180. Did you all try it like this? Sn is equal to minus 180. Did we do it like that?
Yes, ma'am.
Okay, what is the quadratic equation you got?
2n square minus 39n plus 180 is equal to 0.
Very good. Then what are the values of n?
15 by 2 and 12, ma'am.
Very good, Tirunesh. Very good. N is equal to 12 or n is equal to 15 by 2. Now n is the number of terms, and clearly it cannot be 15 by 2. The number of terms cannot be 15 by 2. So n is 12. So then what is x then? It's the 12th term. N is 12 meaning the sum of the first 12 terms is minus 180. N is equal to 12. Let me share my screen now. Good, Tirunesh and Shreya. Yeah, I've shared my screen now. N is equal to 12 or n is equal to 15 by 2. 15 by 2 number of terms cannot be 7.5. So n is equal to 12. Meaning 12 terms are added to get the sum minus 180. 12 terms are added to get the sum minus 180. That means x is the 12th term. 12 terms are added to get sum minus 180, which means x is the 12th term. So we have to find A12, which is A plus 11D. We'll have to find the value of x. And what is x there? It's a term. X is a term there. Which term? 12th term. X is a term. Which term? 12th term. How do we know it's a 12th term? Because n is 12. So x is in the 12th position. It's a 12th term. So we have to find A12 or A plus 11D. And working, we get x is equal to 7. The value of x is 7. Please ask me your questions, children. What doubts do you have? What is not clear, please ask me. A and D, you can find out A, D. Then we need to, have an equation which can be worked to find the value, which can be worked to find something, so which will help us to find the value of x. So the equation is Sn is equal to minus 180. That's the equation. Sn is equal to minus 180. My screen is visible to all of you, right? I've shared my screen again.
Yes, yes, ma'am.
Okay. So Sn is equal to minus 180. So this equation will help you to find the value of n. Because in Sn is equal to minus 180, when you use the formula, you can substitute the values of A and D, but not n. So you get a quadratic equation in n. And on solving that, we get two values for n. 15 by 2 not possible. N is 12. So x is the 12th term. And the value of x is 7. We finished this, right? We finished all this. Yeah, let me show you the answers from the beginning. This is the first answer. Take a screenshot. Just a minute, children. This is the second answer, children. Took a screenshot. So here it's given that the third term is 16. Third term is 16, meaning a plus 2d is equal to 16. And the seventh term exceeds the fifth term. The seventh term is more than the fifth term by 12. So the difference is 12. The seventh term is more, the fifth term is less. The seventh term exceeds the fifth term. The seventh term exceeds the fifth term. So the seventh term is more than the fifth term by 12. That means the difference between these two terms is 12. The seventh term is more than the fifth term by 12. So A7 minus exceeds means is more than. Which is more? Seventh term is more. Which is less? Fifth term is less. How much more is the seventh term? 12. So the difference is 12. A7 minus A5 is equal to 12. So A plus 6D minus A plus 4D is equal to 12. So we have two linear equations. The third term is 16. From that we have this equation. The third term is 16. And when you work this, you will get another equation in A and D. Solve to find the values of A and D and hence find the AP. So this is the first equation. Okay, so second, we don't get an equation. We directly get the value of D. When you work the second one, you directly get the value of D. So when you substitute D is equal to 6 in the first equation, you're able to find the value of A and hence find the AP. This is the fourth one. So clearly the nth term of the AP is X. The nth term is X. AN is X. This one is the nth term. This one is AN. This is A1, this is A2, this is A3. This one we don't know, AN. So the ANth term is X. Now we know N is 12. So the 12th term is X. Now we know N is 12. See, we know N is 12. So earlier we did not know. So the X is the ANth term. But now we know N is 12. So the 12th term is X. 12th term means A plus 11D is X. So work and get the value of X. Am I audible, children?
Yes, ma'am.
Yes, ma'am.
All right. Finished all this. Yeah, this is the next question. Find the sum of all 3-digit non-multiples of 70. Find the sum of all 3-digit non-multiples of 70. So the procedure is like this. We'll understand, listen to me carefully, children. We'll understand all the 3-digit number. We'll divide. Okay, now we have this collection of all 3-digit numbers, correct? Or we have this collection of, it's limited. The 3-digit numbers, they start with 100 and they go on up to 999. The first 3-digit number is 100 and the last 3-digit number is 999. So we have this collection of 3-digit numbers from 100 to 999. Now let's look at these numbers as, let's divide this collection of numbers into two groups. One group which makes the multiples of 17, all the 3-digit numbers that are multiples of 17, and the other group which makes the collection of all 3-digit non-multiples of 17. See, it's your choice. You're dividing them into two groups, that's all. You're dividing all the 3-digit numbers into two groups. You have this collection of all 3-digit numbers. You have the collection of all 3-digit numbers. Okay. From 100 to 999. Now you're making two groups. You're putting some numbers in one bag and the remaining numbers in the other bag. In one bag, you're dropping in all the multiples of 17. All the 3-digit multiples of 17, you're putting them in one bag. And in the other bag, you're putting the remaining numbers, which are non-multiples of 17. So that means, so the collection, we have the entire collection of all 3-digit numbers. Okay, we have the entire collection of 3-digit numbers and we make them into two groups. Multiples of 17, and the other group is non-multiples of 17. Non-multiples of 17. That is, there are some numbers here. The remaining numbers are here. These two put together, this one and this one put together, forms the collection of all 3-digit numbers. So we'll first find the sum of all 3-digit numbers. We'll first find the sum of all 3-digit numbers. And then we'll find the sum of all 3-digit numbers that are multiples of 17. You'll have to generate two different APs. See, the AP for this will be 100, 101, 102, so on up to 999. All right, you need to find the sum of all these numbers. You need to find the sum of all the 3-digit numbers. You need to find the sum of all the 3-digit numbers. After that, here you need to find the AP. See, here you need to find the AP. The AP of all multiples of 3-digit multiples of 17. You need to find the AP of all 3-digit multiples of 17. So generate the AP and find the sum. Find the sum. So you will find the sum of all the 3-digit multiples of 17. So if you call this answer A and this answer B, A minus B will give you this one. A minus B will give you the sum of all 3-digit non-multiples of 17. The sum of all 3-digit non-multiples of 17. That is from the total sum. What is the total sum? What is the total sum? The sum of all the 3-digit natural numbers is the total sum. From that, if you take away the sum of all the 3-digit multiples of 17, if you take away that sum, the remaining sum will be the sum of all 3-digit non-multiples of 17. So from the total,
Can you explain the first one?
Yeah, one second. So from the total, if you take away the sum of all 3-digit multiples of 17. What is left? So from the total sum, if you take away the sum of all 3-digit multiples of 17, you will get the sum of all 3-digit non-multiples of 17. Non-multiples of 17. Okay, let me repeat. So first we need to find the sum of all 3-digit numbers. We need to find the sum of all the 3-digit numbers. So to find the sum of all the 3-digit numbers, you need to generate the AP. And the AP is 100, 101, so on till 999. Find this sum. From this, you must take away the sum of all 3-digit multiples of 17. Take away the sum of all 3-digit multiples of 17. So generate the AP. I'm not helping you to generate the AP. You need to generate the AP. That is the AP of all 3-digit multiples of 17. To find the sum, you should first generate the AP. Generate the AP. It's not the same AP. This one will be a different AP. Generate the AP of all 3-digit numbers which are multiples of 17 and find their sum. The difference when you subtract the sum, when you subtract the first one, when you subtract these two, you will get the sum of all 3-digit non-multiples of 17. See, the entire collection from 100 to 999 has numbers which are multiples of 17 and non-multiples of 17. So first find the total sum. So that sum is the sum of all multiples of 17 and the sum of all non-multiples of 17. So from that, if you take away the sum of all the multiples of 17, the remaining will be the sum of all the non-multiples of 17. We'll work it, and if we still don't understand, we can see it again. We'll first start working. I'm not showing you the answer slide like I always do. I want you to try it. This is the procedure. You may start like this. AP of all 3-digit numbers. Then what are they? 100, 101, 102. Now find the sum. Tell me, when you find the sum of these numbers, tell me the sum. Yeah, start working, write the question, start working.
Ma'am?
Yeah?
Ma'am,
Yes, Nivedita?
16.
Oh, this
Yes, ma'am.
Nishita.
6th question also you gave us homework, ma'am.
Priyadarshini, is it?
Yes, ma'am.
Yes, Priyadarshini.
Ma'am, 6th question also you gave us homework, ma'am.
Oh, really? Okay, I'm sorry. Thank you, Priyadarshini. See, nobody mentioned that. Thanks, Priyadarshini. Okay, let's do this. If 7 times the 7th term, so see here, 7 times the 7th term is equal to 11 times, 7 times meaning 7 and 2. 7 times the 7th term is equal to 11 times. Times means multiplication, the 11th term. If 7 times the 7th term is equal to 11 times the 11th term, find A18. Just work this. So 7 into A plus 60, because A7 is A plus 60, is equal to 11 into A plus 10D. So when you work this, you can see here, minus 4a minus 68d is equal to 0. This is what you get on working. Take out minus 4 common. You get a plus 17d is equal. You can take out 4 also common or minus 4. You can change the signs throughout. See, how you proceed is your style. You can change the signs throughout. Then you will get 4a plus 68d is equal to 0. You can change the signs throughout. Or you can take out minus 4 common. Then you get a plus 17d is equal to 0. So a plus 17d is equal to 0 by minus 4. A plus 17d is equal to 0. 17 can be written as 18 minus 1. A plus 18 minus 1 into d is equal to 0. That means the 18th term is 0. A plus 18 minus 1 and a plus 17d is the 18th term. A plus 17d is equal to 0, meaning the 18th term is 0. A18 is 0. So there's a condition given to us 7 times the 7th term is equal to 11 times 11th term. When we work with that condition, we get one equation in A and D. We get minus 4a minus 68d is equal to 0 on taking minus 4 common, or you can change the signs throughout and take 4 common. You can change the sign throughout and take 4 common. Okay, so you get a plus 17d is equal to 0. A plus 17d is equal to 0. A plus 17d is equal to 0, meaning A18, the 18th term is 0. Let's continue with this. Have we started working this? Have you started working this, children? Okay. So this is like a test. Let's see, you can check how well you have understood and how careful you are. Sometimes we might have understood the concept, but we are careless. We don't calculate carefully. That also cannot be excused. You'll have to understand the concepts clearly, practice, and also work carefully. All put together only you will get good marks. Yes, what is the sum of all the three-digit? What is the sum of all the three-digit natural numbers? Okay, how many three-digit natural numbers do we have?
$900.
900, is it?
Yes, ma'am.
How do you work that, Tirunesh?
I'm using AN formula, ma'am.
Very good. AN is equal to what?
100 plus n minus 1 into 1.
No. AN is equal to which? What is the value of AN?
999.
Very good. Very good. So N is equal to 900. Yes. Next step. What is the sum of all these 900 terms?
4,94,550, ma'am.
That's good. You're right. Yeah, please proceed. To find the sum, we need to first find how many terms. We need to find the value of n, because sum to how many terms? Sn you want to find. What is the value of n? Sum to how many terms? So we need to first find the value of n. That is, you should know how many terms are there in this AP. From 100 to 999, you should know how many terms are there. So for that, you should go to the number 999, the last number, and check its position. You must find where it stands. This number 999, the position of 999 is what you want. So when you work AN is equal to 999, you can get the value of n, which is 900. Now, once you get the value of n, you should find Sn. Sum to 900 terms. There are 900 terms. From here to here, there are 900 terms. So S900 is equal to n by 2 of the first term plus the last term. N by 2, 900 by 2 of the first term plus the last term. You can also use the formula n by 2 of 2a plus n minus 1 into d. You will get the same thing. Sum to 900 terms is equal to 900 by 2 of the first term plus the last term. And this one works too.
Ma'am,
Yeah.
ma'am, the answer is 4,65,718.
Tirunesh, the final answer is it?
Yes, ma'am.
4,65,000.
718.
Very good. You're right. Is it possible for you to take a picture of your answer and share it on WhatsApp now? Is that possible?
Ma'am, I have done it in pencil.
No problem. I'll be happy to see that. No problem.
Yes, ma'am.
If that's not a trouble, please do it. Yes. Somebody tell me, not Tirunesh, somebody tell me the AP of all the 3-digit multiples of 17. What is the first multiple? What is the first 3-digit multiple of 17?
102, ma'am.
102. Very good. 102. And what is the last 3-digit multiple of 17?
986.
986.
Very good. Okay. 986. And what's the value of n? See, children, to find the sum, you need to know the value of n. Without n, you cannot find the sum. Sum to how many terms? Sum to 10 terms, 20 terms, how many terms? So you need to know the value of n to find the sum. So you should go to 986 and ask 986 its position. So an is equal to 986. What is the value of n?
53.
53. So you will find S53. What is S53?
28,832.
Perfect, Arna. Yes, 28,832. And the difference is the sum of all the 3-digit non-multiples of 7. Very good.
465,718.
Yeah. Those are finished, please check your answer. So the sum of all the 3-digit numbers is this one. And this is the sum of all the 3-digit multiples of 17. The difference will give us the sum of all 3-digit non-multiples of 17. Srinivasan, your calculation. You've shared your answer on WhatsApp, Srinivasan. Good. Your calculation, that first part, you got 4,93,901. How can you get 901? You cannot get 450 into 1099.
I will check, ma'am.
Yeah. This one, for this you got 4,93,901. How can you get 1 in the end? It has to be a 5, right? Meaning it will be 0, then 9 5s are 45. 5. Got 1 here. It's wrong.
Yes, ma'am.
Good, Tirunesh. Okay, good, Arnav, Tirunesh and Srinivasan. Yes, Srinivasan, you were not audible. You've texted me.
Am I audible, ma'am?
Now you're audible. Yes, yes, I can hear you. Srinivasan, right?
Yes, ma'am.
Yeah. So early you were not audible.
Okay, ma'am.
Yeah. Yes, any questions, children? Children, to find the sum, you need to know how many numbers. You're trying to find the sum of how many numbers. You need the value of n. Only then you can find Sn. So how will you find n? You should go to the last number in the AP. The last term in the AP will tell you the number of terms the AP has. So it's first about finding n. First we'll have to generate this AP, then find n and Sn. Then generate the next AP, multiples of 17. Find n. How many are there? There are 53. There are 53 3-digit multiples of 17. There are 53 3-digit multiples of 17. And then find S53, the sum to all the 53 terms. The difference will give you the sum of all the non-multiples of 17, 3-digit non-multiples of 17. Your questions, children?
Clear, ma'am.
No doubts, ma'am.
All right. Let us first, we should find the total sum. From that, if you remove multiples, you will be left with the non-multiples. Okay, now the question is, why are we not finding the sum of the non-multiples straight away? Why this method? Because the numbers that form the collection of numbers which are 3-digit non-multiples of 17 will not form an AP. So you cannot do it directly. So like the first, so see here, 100 is not a multiple of 17, 101 is not a multiple of 17, 102 is a multiple, then 103 is not a multiple, 104 is not a multiple, 105 is not a multiple, 106 no, 107 no. So what you should try to understand is this collection or this sequence of numbers will not form an AP. If you write down the collection of all 3-digit non-multiples of 17, you will get a collection of numbers. You will have a sequence of numbers, but they'll not form an AP. So you cannot find the sum straight away. You have to do this. Because the collection of all the 3-digit numbers, they form an AP. The collection of 3-digit multiples form an AP. Multiples of 17 form an AP. So these two, you'll have to subtract these two to get the answer. You cannot find the sum straight away because the collection of the 3-digit non-multiples of 17 do not form an AP. This is simple, children. Practice this. I'll show you the answer slide. Take down the question. So we know that an is a plus whatever is this minus 1, n minus 1 into d. So if you want to find if you want to find a5, it will be a plus 5 minus 1 into d. So if you want to find a n minus 1, the n minus 1's term, it will be a plus whichever term here you'll have to find n minus 1 minus 1 into d. Because it's always like that. N, if you want to find the nth term, n minus 1. Fifth term, 5 minus 1. N minus 1th term, n minus 1 minus 1 into d. So the n minus 1th term will be a plus n minus 1 minus 1 into d. Whatever is here, minus 1 into d. Finish working this, children?
Yes, ma'am.
Okay. So we have an AP, we need to find the n minus 1th term and the sum to the 10 terms. We need to find a n minus 1, that is the n minus 1th term and the 10th term. I'm sorry, and the sum to the first 10 terms. Yeah, this you can take a screenshot, children. We have done a sum similar to this. Take a picture. So the sum to the first 5 terms is 90. The sum to the first 12 terms is also 90. First 5 terms is 90. Then if the first 12 terms is also 90, that means the sum from the 6th to the 12th is 0. From the 6th to the 12th is 0. From the 6th to the 12th is 0. The double answer is because the sum of the numbers, the sum of the terms from the 6th to the 12th is 0. The sum is 0. So the questions which we are going to work from now will actually be given in words. I have presented the question using symbols. So this question will be like, if the mth term of an AP is 1 by n and the nth term is 1 by n, then find the sum to the first p terms of the AP. Sorry, then find the pth term of the AP, the mnth term of the AP, and the sum to the first mn terms of the AP. So whatever, so that the question is mostly given in words. Find will be given in symbols, but that information am is equal to 1 by n will not be given to you straight away. An is equal to 1 by n will not be given to you. An is equal to 1 by m will not be given to you straight away. It will be in words. If the mth term of an AP is 1 by n and the nth term is 1 by m, then find all this. Write down the question, children. Done, children?
Yes, ma'am.
Yeah, somebody read the question for me in words. If the
mth term of an AP is 1 by n and the nth term of an AP is 1 by n.
correct. If the mth term of an AP is 1 by n and its nth term is 1 by m, then find the three subdivisions given there. So when it's given in words, we'll first convert it to symbols like this. It will be given in words, so we'll convert it to symbols like this. The mth term is 1 by n, the nth term is 1 by m. Mth term means a plus m minus 1 into d is equal to 1 by n. And the nth term means a plus n minus 1 into d is 1 by m. So now we have two equations. We'll have to solve the two equations to find the values of, to find the expressions for a and d. So write the equations one below the other. This one, you can see it here. You can see this here. Change the signs. A minus a gets cancelled. So you have m minus 1 into d minus the new sign minus n minus 1 into d is equal to 1 by n minus 1 by m. This one minus this one is what you see here is equal to 1 by n minus 1 by m minus the new sign. So now this will be m into d. You can open the bracket. I've taken out d common. You can also open the bracket. I've taken out d common straight away. I'll tell you now what to do. Now you are trying to find the expressions for a and d. So you should take out d common in this equation. In this equation, you don't have a. You don't have a in this equation. You have only d. So you'll have, because we eliminated a, right? We eliminated a. So we are trying to find d from this. That's what we do in the elimination method. Supposing we have to find the values of x and y. If you have eliminated x, that means you're trying to find the value of y. Similarly here, we have eliminated a. We have eliminated a. That means we are trying to find the value of d. So how do you find the value of d? Take out d common. D is in two places. It's here and here. So take out d common. Take out d common. So when you take d common, so d is here, d is here. When you take d common, you'll get m minus 1 into d minus, let me use a square bracket. Let me use a square bracket. See here, square bracket d. All right. I'm telling you how to take out d common. So square bracket d. What do you have here? m minus 1 into d minus n minus 1 into d. M minus 1 into d, n minus 1 into d. M minus 1 into d minus n minus 1 into d. So then the next step will be m minus 1 minus n plus 1. That's how we get plus 1 here. I'll show you again, children. We have eliminated a, so we are trying to find the value of d. That's the first thing. D is in two places. We need it in only one place. Only then you can find the value of d. Okay, so just open and close a square bracket. D is equal to 1 by n minus 1 by m. All right. So m minus 1 into d minus n minus 1 into d. You can also take the LCM here. You can take the LCM. So when you open the bracket, m minus 1 minus n plus 1 into d is equal to m minus n by mn. Now minus 1 plus 1 gets cancelled. So m minus n into d is equal to m minus n by mn. So d is equal to, now m minus n on either side gets cancelled. On either side, m minus n gets cancelled. So d is equal to 1 by mn, or if you want, you can bring it down for division. D is equal to m minus n by this m minus n will come down for division. M minus n into mn. D is equal to m minus n by this m minus n will come for division into mn. So m minus n gets cancelled. So d is equal to 1 by mn. This is the expression for d. D is equal to 1 by mn. Substituting d is equal to 1 by mn in equation 1, we get this is equation 1. This one is equation 1. Instead of d, we are going to say 1 by mn. Because that's what we do, right? Once you get the value of one unknown. So here d, we got the expression for d. Now we'll have to substitute and get the expression for a. So we take up the first equation. A plus m minus 1 into d. D is 1 by mn is equal to 1 by n. So now m minus 1 into 1. M minus 1 into 1 is m minus 1 by mn. A plus m minus 1 by mn is equal to 1 by n. A plus m minus 1 into 1 is m minus 1 by mn is equal to 1 by n. So take to the other side. We are trying to find the value of a, or the expression for a. So transpose 1 by n minus m minus 1 by mn. Mn is LCM. So we get m minus m, minus into minus plus 1. Minus into minus plus 1. Mn minus m gets cancelled. So a is equal to 1 by mn. Yes, children, right? We haven't finished. We've only got the expressions for a and d. We still need to find AP, AMN, and SMN. That is the pth term, mnth term, and the sum to the first mn terms. We need to first find them. I'm sorry, we need to still find them. Write down till here. Have we started writing? Are we writing, children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. Please understand and write. Don't blindly copy. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. So now let's find the first one, the pth term. So the pth term is a plus p minus 1 into d. We know this. The pth term is a plus p minus 1 into d. And we just found we have to substitute the values of a and d. That's all. Like we always do. We have to substitute the values of a and d. A and d. A we found is 1 by mn. D is also 1 by mn. A is 1 by mn. D is also 1 by mn. So substitute the values. We know that the pth term is given by a plus p minus 1 into d. A is 1 by mn. D is also 1 by mn. So 1 by mn plus p minus 1 by mn. You understand that? P minus 1 into 1. The fraction. See, if you have 5 into 1 by 4. 5 into 1, 5, 5 by 4. 5 by 4. Similarly, p minus 1 into 1 is p minus 1 by mn. Then mn is a common denominator. So we have 1 plus p minus 1 plus 1 minus 1 cancels. So p by mn. Children, the pth term, this is the expression to find the pth term, a plus p minus 1 into d. Substitute the expressions for a and d we got. Substitute the expressions for a and d. That's all. That's all. So that's about the pth term. Now the mnth term. Mnth term is a plus mn minus 1 into d. Mnth term is a plus mn minus 1 into d. So substitute the values of a and d, values of the expressions of a and d. This is a, this is d. So 1 by mn plus mn minus 1 into 1 is mn minus 1 by mn. When you multiply these two, this is what you get, mn minus 1 by mn. Mn is a common denominator, cancel, so mn by mn, which is 1. The sum to mn terms is mn by 2. That is, if you're finding the seventh term, it is 7 by 2. If you're finding the nth term, it's n by 2. Whichever term you're finding, that one by 2. So Smn, meaning the mn, the sum to the first mn terms. The sum to the first mn terms. The sum to the first mn terms is given by mn by 2 of the first term plus the mnth term. See, related to this, S10 is equal to 10 by 2 of the first term plus the 10th term. S10 is equal to 10 by 2 of the first term plus the 10th term. So Smn will be mn by 2 of the first term plus the mnth term. So, so we have to substitute for A1, which is, we'll have to substitute for A1, the first term, which is 1 by mn. And the mnth term we found here. The mnth term is 1, we found here. So mnth term is 1. Mn by 2 is mn by 2. So mn by 2, common denominator. Here take the common denominator. Mn is a common denominator in the bracket. Mn is a common denominator. So you get 1 plus mn by mn. Mn and mn gets cancelled. So 1 plus mn by 2 or mn plus 1 by 2. Or you can also use the other formula, sum to the first mn terms, the other formula. mn by 2 of 2a plus mn minus 1 into d. If it is Sn, you will say n by 2 of 2a plus n minus 1 into d. It's mn. So instead of n, you should say mn. mn by 2, mn minus 1 into d. So mn by 2, you can work the third subdivision like this using this formula, first term plus last term, or 2a plus n minus 1 into d. mn minus 1 into d. So mn by 2, 2a, what is a? What is a we found here? 1 by mn. What is a we found? 1 by mn. What is 2a? 2a, 2 into 1 by mn. So 2 by mn. 2 by mn. 2 by mn. 2a is 2 by mn. Plus mn minus 1 into d. D we found 1 by mn. So mn by 2, mn by 2, 2 by mn plus multiply this into this. Multiply this with this. mn minus 1 into 1, mn minus 1 by mn. mn minus 1 into 1 is mn minus 1 by mn. Now the common denominator is mn. So 2 plus mn minus 1. mn gets cancelled. 2 minus 1 is 1. 2 minus 1 is 1. 1 by 1. We have 1 here. 2 minus 1 is 1. And we have mn here. This mn in the denominator and numerator, they get cancelled. So we have 1 plus mn by 2 or mn plus 1 by 2. Please write this, children. I'll just get back. So as I told you, the question will be given in words. You'll have to read that and convert it to equations using symbols. So like this, the mth term. Then construct the equations, solve the equations to get the values of the expressions for D and A. As we always do, when you have two equations in x and y, you solve them to find the values of x and y. So here, we are working with arithmetic progressions where we need to know the values of A and D, the first term and the common difference to get the AP. So solve the two equations to find the expressions for D and A. That's a preparation. We haven't still answered these questions. We haven't still found AP, this one or this one. To answer these, we need the expressions of A and D. To answer subdivisions 1, 2, and 3, we need the expressions for A and D. So we solve these two equations and get the values of A and D. And then we answer them one by one. So this is the formula. And in this formula, substitute what you've got for A and D. And hence find AP or the pth term. Mnth term is A plus Mn minus 1 into D. Substitute for A and D. You found expressions for A and D, substitute. And that's the mnth term, which is 1. Sum to mn terms, you can do it in two ways. You can use either of the two formulae. N by 2 of the first term plus the last term, or n by 2 2a plus n minus 1 into D. So here n is mn. First term is a1, last term is the mnth term, amn, which we have found here is 1. Or when you use this formula, the term, like Sn, here it is as Mn, so Mn by 2. The common difference is 1 by Mn. 2a, A is 1 by Mn. 2a, 2 into 1 by Mn, so 2 by Mn. You need to substitute for A and D everywhere. You need to substitute for A and D. A and D. So here, this is Mn. Sum to Mn term, Mn will be Mn. The first term you'll have to substitute, and the last term, Amn, is 1. Here you have A, N, and D, right? N is Mn. N is Mn. A and D. You should substitute for A and D. What are your questions, children? Let's make it more clear. All right. Yes, children. Take this question and work this one and tell me the answer. Find the sum of all odd multiples of 7 between 700 and 3000. Find the sum of all odd multiples, not even multiples, odd multiples of 7. See, 7 has both even and odd multiples. The multiples of 7 alternate between even and odd. 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28, 35, 42. Even, odd, even, odd. Find the sum of all odd multiples of 7 between 700 and 3000. Between 700 not included, 3000 not included. Because between, not from 700 to 3000. No. Between 700 and 3000. Not including 700, not including 3000. That also I told you now. If I didn't tell you, maybe some of you would have gone wrong by taking 700 also. It's an even multiple. I'm just telling you. Between means not including 700. 700 not included. 3000 not included. Are we ready? Do it. Let's see who can answer this first. To find the sum, you should know how many numbers. So first you should generate step 1, generate the AP. Step 2, find how many multiples are there, how many odd multiples. N you should find, and then find SN. Generate the AP, go to the last number and ask that last number its position. So you will get the value of N. And then find SN. Yeah, be the first to answer quickly. Yes, what's the value of N, children?
Ma'am, 328, ma'am.
No, Priyadarshini. N is not 328.
Ma'am, is it 170?
Ma'am, 164.
Okay, 164 from Tirunesh, and I got another answer.
174.
No, I think you. No, I think you've made some mistake in calculating, Arnav. It is 164. Even you have got it. Check your calculation. 164 is the correct answer. Is the correct value of n. Priyadarshini, read out the AP. I think you've taken all the multiples instead of only odd multiples. Read your AP.
Ma'am, 707,
Yeah.
714.
Why did you take 714? That's an even multiple of 7, right?
Yes, ma'am. First I took sum of all multiples of 7, ma'am.
Okay, then
Then I took sum of all even multiples.
that's a double work. No, you can directly find odd multiples.
Oh, yes, ma'am.
Yeah. So that value of n you said is the sum of all the multiples of 7, is it?
Yes, ma'am.
Okay, okay. Okay. Well, since I don't have those steps, maybe you're right. $328 is right, yeah. Because now we got 164, right? Should be correct. 328 should be correct. But Priyadarshini, I wouldn't encourage that procedure because you can directly find, that's a roundabout. You can directly find, the number of odd multiples between 700 and 3000. Please do it that way.
Yes, ma'am.
Yeah. Now tell me the AP, Priyadarshini. Will you take 700?
No, ma'am.
707?
Yes, ma'am.
714?
No, ma'am.
Okay, the next one, 721?
Yes, ma'am.
Yeah, so like that, leave the even multiple, take the odd multiple. So what do you think will be the common difference? Okay, will the common difference be 7?
No, ma'am. 14, ma'am.
Yeah, the common difference will be 14. Yes, Priyadarshini, please do it that way.
Yes, ma'am.
Ma'am, is the answer 302,498?
You're close, but not correct.
Ma'am, 3,03,072.
Yeah, correct. 3,03,072. Good, Tirunesh. Very good. 3,03,072. Class, use the emoji, raise your hand. Manasa, Shivani and Priya, I hope you're all there. Shivani is there, okay. Manasa. Okay. So Manasa, I hope she's attentive. Priya, I hope you're also attentive. You've not raised your hand, both of you. Shivani, Akshay-Ram, Bala Harish, Shabarigrish, Sudarshan, Shriya, Harshita, Muttuvel, Priyadarshini, Parkavi, Nishita, Hariharan, Nivedita, Srinivasan, Nafi, Lakshita, Arnav and Thirunesh. Okay. All right, children, I think it's time to see the answer. As I told you, the procedure goes like this. First, the AP is 707, 714, okay, 714, 721, 728. Let's take 700. 700 not included, okay. So what's the last number, children? Okay, let me do it.
2,968.
2000?
968.
Cannot be so small. 968.
2,989.
Yes, ma'am, 2,989.
No, I'm looking for the last number here. 1 second.
Ma'am, 2,996.
96, huh? Okay. 7
Yes.
4 28. 1 is a remainder. 7 4 are 28. 5 is a remainder. 7 8 are 56. Yeah, correct. Okay. So children, these are the numbers. These are the multiples of 7 between. See, 700 we should not include because it's between 700 and 3000. So these are the multiples. These are the multiples of 7 between 700 and 3000. But they don't want all multiples, only odd multiples. So don't take this. Don't take this. 707. 714 will not come. 721. 728 will not come. 735. So like this, it goes on till this is an even multiple. This is an even multiple. So it's preceding the multiple preceding this will be 2996 minus 7. So 892 2989 2989. You write out all the multiples of 7 between 700 and 3000. You cross out the even multiples. So the remaining are the odd multiples. But this one is an even multiple. So if you take the one after this, it will go beyond 3000. If you add 7 and take the next multiple, that will be an odd multiple, but it will be more than 3000. So subtract 7 and take the earlier multiple. That will be the odd multiple required. So this is the AP, where the common difference, where the first term is 707 and the common difference is 14. 14, 721 minus 707, 14 is a common difference. AN is equal to 2989. Find the value of N. Find the value of N. Then find Sn. As some of you said, N is 164 and Sn, the sum of all the odd multiples, is 303072. This working is to find the last number, children. I hope you understand the last number. The last number you can do it like this, or you can also say, 7 into 428. 428 into 7. 7 8 are 56, 5 carry over. Same number you will get. 14, 19, 9, 1 carry over. 7 4 are 20, 29. You can also do it like this. 428 into 7. See, what I have done is, when you divide 3000 by 7, it leaves remainder 4, right? So if you take away that remainder, that number will be exactly divisible. Is also correct. What I have done is 3000 is not divisible. Remainder is 4. So take away the remainder. 3000 minus 4, 2996 will be divisible by 7. You can also do 428 into 7. So first find n and then Sn. If you've not finished, please take a screenshot, children. Take this question as homework. We'll see the answer to this question in tomorrow's class. This is your homework. Find the sum of all 3-digit numbers that leave remainder 13 when divided by 15. All right, children. So that's it for today's session. Thank you so much. If you have any doubts, please ask me. You can stay back and ask me, else you may leave the meeting. Thank you. Good night.
1 minute, can you show the answer of the first question?
Yeah, sure. This one, huh?
The answer, ma'am, first question.
Yeah.
Yes, ma'am. Thank you, ma'am.
Fine. Thank you. Good night, children.
Thank you.
Thank you, children. Good night.